last session, and probably you might have been already tired a lot, right? And I hope I will make it a little bit interesting and something you'll know, something new, right? And just a quick question. So how many of you guys know confidential AI or confidential computing, the new term? Oh, one person, great. So yeah, today I think then many of you will be learning something new. New means term by the new, but yeah, like there might be already someone knowing about this security part. So yeah, great. So let's move forward, okay? Just a minute. Yeah. So myself, Yatindra Shashi. I'm from the Intel, and I'm working as a cloud and AI solution engineer. And I have been in Intel almost around like 5 years, but in tech domain more than like 10 years I have been working there, right? So, and currently I'm working more on the cloud and AI part, and AI means currently the Gen AI part that I'm currently working, right? So, and I was in Berlin because I did my master in Berlin. So yeah, I was there for almost 3-4 years. I worked in Fraunhofer also. So like yeah, I'm aware of this environment. Yeah, I think in LinkedIn you can easily reach me because there are few people with my name because it's like a little bit unique. Yeah, and feel free to ask any questions if you have in the middle of this talk, and even after the talk also you can be asking me the questions, right? So let's move forward. As like it's big companies, they already have some legal notices, right? So the legal notice just said about that, okay, whatever we claim here is not that we don't say like 100% is secure and 100% we claim that it will be secure. There's also the scenario that like some of the performance, if I share, then these are like on specific requirement, specific use cases, and other brands are like claimed by other brand owners, right? So today in the talk, we'll come to know about why confidential AI, right, and what exactly it is, right, and so that like you can understand, okay, probably what you'll learn from this talk, right, from the very beginning. And then confidential computing, which is like foundation of fostering this trust-based confidential AI. And then some customer spotlight, because I feel that the more you know that the use cases and where the customer are using it, that more trust it will be built in the ecosystems, right, how it is used. And then, of course, I want to show the small demo, right? There you'll see that how this open source platform called Opia, Enterprise for AI, has extended this confidential computing and like using the Gen AI use cases, how it has like able to confine the security breach that was possible before without confidential computing. And now, yes, I think many of us already heard in multiple call, right, or multiple sessions that agentic AI is now moving forward, right? So like with agentic AI, how it is much more important. That will be in whole talk we'll learn. So we know now already that AI is very powerful. Many people uses it, and I think many people are already using in their mobile, like at least ChatGPT, right? But we know that like it's very vulnerable. It is, and I think if you have not seen it, there are some news that show that like even OpenAI has more than 1,000 times the data breach, right? If I say like as we move agentic, there was some other news, is like at least in this healthcare sector, in Catholic Health in US, there was a data breach of the patient data, right? Also, there was in the like agent force from the Salesforce, there was also like Force leak has shown that there was vulnerability possibilities, right? I think this news also you have seen long ago that in Samsung they use the ChatGPT and the employee has accidentally asked something of their like proprietary data in the Samsung, and then after the few days another employee asks and they get the similar answers from this. So like, okay, where is the data? Like, is it protected or not? So AI is very powerful, but at the same time, we should be also taking care about the vulnerable possibilities, right? And today I'm talking about confidential computing perspective, so how this could be done. So like now we know, right, the innovation like this Gen AI and there are a lot of use cases that different customers and different companies are trying to bring to the customers, right, to the users of to use it, right, and get their life much more easier to do it, right? But at the same time, there are the regulations, right? The regulations are made so that all those technologies that is coming forward, is it something that could be good for the human race, right? Is it ethical? Is it responsible, or it has some more issues? So the compliance, regulation, and innovation many times doesn't go side by side. There's like a lot of problems, right? But in today's talk, I'm going to talk a little bit about some data privacy and data security part, like how this confidential computing is able to solve it, right? I think probably you know, like GDPR, EU Artificial Intelligence Act, and US also have some act, like, and different countries have this type of act, right? So which says, okay, when you have these AI applications, you have to comply with certain rules and regulations. There is data sovereignty things, and but it's very challenging that we have seen, at least in different customer use cases, when the data is exactly in use, it's very difficult to find it out where it is. I mean to say, which cloud provider, which location, where it is. It's sometimes very difficult to trace it out, right? And the confidential computing at least helps in the cloud service provider, that even the cloud service provider didn't have the access of the data. So this is very important, at least in the cloud workload, or even also in furthermore that in the like on-prem workload also, this will give you a protection of your data that's inside your like compute environment, right? So this has at least helped to make the compliance and innovation together. And this is fostering that things. And like in Berlin, I think last week also there was, not last week, I think a few months ago, confidential computing forum was there, like a lot of companies are there, which I will show in the last slides, who are like fostering these technologies together to win this world, right, with this type of, solving this type of problems of the compliance. Probably you might have seen in another talk also the people talking about time series and federated learning. Maybe in other talks also there was few things related to the federated learning. Maybe you know or not, but let me describe a little bit about it, like what difference it is, right? So one is centralized learning. Many people know it, like data moved to the server where you wanted to train your model, and that's centralized learning, like everything in center one place. But in federated learning concept, the model exactly moved to the data, and then the training is happening there, and the weights are consolidated in the center part, and the model is created, right? And this is really, really useful, and we have seen multiple customers that I will also see in customer spotlight, that for the healthcare sector, where the patient data are very crucial, right? There are in the financial sectors where this finance information is very crucial. So in these sectors, we have seen this federated learning is very much popular nowadays, right? And like from the Intel, we have also contributed something called OpenFL, this Linux Foundation project, right? And it helps to run your federated learning. But still here, there is one problem. The problem is that still this hospital and the aggregation server who provides this model still have a like paper-based binding where they say that I trust that your model weights will not be stolen, and also like the hospital believe that the model owner will not take my private patient data or something like that. Still that is there. But is there a way that third party can verify it, not just the two party who is taking part of it, right? So this is where the confidential computing also helps it, right? So to verify this type of scenarios. Another scenarios like as we move forward with the now like AI and Gen AI use cases, we have this is just one example that I wanted to give you guys. So like this Hugging Chat is a service provider, right? Which is giving you like probably chatbot, and they are serving a proprietary model. So for example, like model owner is from XYZ company who has ABC model, right? And you are the user of that model, and you are asking something, right? Now if you see in the behind, this Hugging Face or Hugging Chat is also running their algorithms or whole framework on some type of like cloud service provider. Many times this happens, like either AWS or Azure sometimes, right? So like, but still the question comes, does this service provider and infrastructure providers, means Hugging Face and like cloud providers, have the no access of your prompt or no access of your data that's in use? Can you guarantee it? We don't know, right? And this is where the confidential computing helps you to verify those type of scenarios, right? So this was one use case. Another is now like as you move from the agentic, now I think many places you have seen that normal RAG is no more like moving towards the agentic. In agentic workflow, we have seen that like you have different states, right? And states even last longer, like intermediate states, right? And all this context of one state to another state, which means one agent to another agent, and even the tool call, all the things are stored inside the memory, right? So which means memory is increasing a lot, right? At the same time, memory is increasing, and even it stays for longer, not like 1 minute or 2 minutes. Even we have seen the case that even the data was stored for like 56 minutes there, right, in the memory, the whole context, because this algorithm was trying to solve one specific task, and until the task is solved, it was trying to store all the information inside the memory, right? So, but in memory, most of the time, if you guys know or not, like data are unencrypted. So if you are able to have the access, and if you wanted to dump the memory, that I will show in a small demo also, you'll be shocked. You can see all the data that's inside the memory, right? So that is something where if you have a personal information, because nowadays we have seen that there are something called travel agent, right? Like a travel agent allowing to book your ticket, right? And you allow that travel agent to have your personal information. At the same time, even some people even allow it to have like credit card information so that they can automatically book your ticket. As you ask, okay, book my ticket from Berlin to like Munich or somewhere, and it just do it, right? So are they safe? So I'm interested in the memory. If someone has, or some malicious people have this type of access, they can look it from your memory, that all the information, and they can do the misuse part of it, right? So this exactly increases the larger surface area. The agentic AI is increasing more the surface area for this type of issues, right? Like where your data leak could happen and it can have the negative repercussion. And it's not only the one data leak, but in agentic world, it's like one flow to another, another flow to another. So this will be even repercussive, and it can affect the whole organizational systems, right? So yeah, this is also the one challenge that we have seen it. So we talk a lot about the why we wanted. We've seen like federated learning, which is like agentic AI, even the chat services, right, and even some news is about it, right? So, but I shared like many times here, confidential computing can fix it. But what exactly it is? So we know that data in rest is the storage. We have very nice algorithms already placed, right? Data in transit with like some security in the network layer we have there. But what about data in use, right? As I said now that we are using a lot of memory, like all the data are in memory computation. It's very easy to decrypt it, very easy to dump it and see it. So is there a way to encrypt the data inside the memory? This is where the confidential computing comes. So confidential computing is giving a trusted execution environment in the hardware level. So in the memory level with the CPU, and as well as like the memory where the CPU is giving the sending the messages, these all are encrypted, right? And this encryption, I'll talk more about it. So this encryption environment gives you the isolation. So like the three essential part that I see here that gives is like isolation. So isolation means, for example, you have a very sensitive application, right, which runs sensitive data, right? And at the same time, you don't want this to be accessed by someone else. So for example, you run one application in cloud service provider like Azure or somewhere, but you don't want Azure or like AWS to have the access of those data, right? And this is where the isolation is given by this confidential computing, the hardware level of isolation, right? Yeah, okay, someone tells, okay, this is given, but is it way that I can verify it? There are the way. So like it's not that, okay, Intel's claims with the Azure that, okay, we give the trusted education environment and you just believe on us, right? So there are way to prove it as well, that there could be the third party who will give you a cryptographic level of proof, right? So this trusted education environment is what is claimed, and this is open source and standard way to do it. There is community behind it. So third party will be able to do it. And there are a lot of talks going on with the government authorities that, okay, the government authorities will be taking responsibility probably to give this type of services, so that all the companies who host their services in the cloud or like wherever in trusted education environment, they can trust that if government services is giving the certificate of like it's running in the trusted education environment, yeah, then we are probably the compliance with this, yeah. Yeah, that's what I was going to talk in the next slide, exactly. Yeah, so I think, yeah. So like one features that Intel CPU has, like Intel SCX, right? So Intel SCX is more like application level of encryption that gives a very small trust boundary, and this has been used by AOCA. I don't know, like if you know the insurance provider here, right? Many of us know, like they use this small layer of the trust boundary to prevent the like patient data and patient informations, right? This type of things. Like even this is highly used in type of like a credit card or like any transactions that happens, right? So this is small, just a small trust boundary. But the problem is this one, like you need to modify your app, right? The another thing that Intel is offering, like called Intel TDX. So this is a VM level of isolation. So in this case, you don't need to modify your app. You have the trusted education environment like a VM. You just run your workload that you wanted to run, which is sensitive, and you trust that workload, right? You run on this VM, and yes, the memory will be protected. But I'm again telling it here that this things is generally giving the memory protection, okay? But if you wanted to protect the data in storage and data in transit, you have to use other encryption methods that's already in place, right? And you remember, like I was telling also about verification, so attestation things. So there's another service that Intel gives this one, like Intel Trustworthy, which is like cryptographic way of verifying that the application or like for example, the VM that claims to be running in the trusted education environment is really running in the trusted education environment or not. So, and this trusted service is even could be offered by some other service provider as well. So now we talked about technology, we talked about why we need it, and now I wanted to show like how this has been used with some of the customers, right? So I think most of know about the Bosch. Like Bosch has something called ADAS systems developing, so autonomous driving assistance systems, right? And in autonomous driving systems, probably we are familiar that okay, we need a camera footage of the street, right? And when you need the camera footage, generally you collect something like personal information of the people that's in the street and even the car number plates, right? So these are like very sensitive information, and GDPR doesn't allow this type of information to be used, right? So how this could be solved, right? So these two things that is that need to be running on the encrypted environment and as the same time trusted execution environment, right? So, but at the same time, I have seen like many people say, okay, why not to blur the face of the people and maybe like it will, or blur the number plate or something like that. Like, but for this, when we talk with these companies, like probably when you want to really make a driver assistance system which is really realistic, no, it need really the face expression as well, the age as well. Like when it walking on the street, it was looking this way, or how it was looking, and so like there are a lot of metrics that need to be carried forward so that you can make a really nice system. So this is not like just by blurring the things could help it, right? So for that cases, what we have done together is that we take the raw footage from the camera and put it on the Intel SCX environment, like secured enclave environment. So all of your data of the personal identification information, right, from the beginning, from the camera till it goes to the training, it runs on those enclave, like secure enclave. It contain all the data is moving on this enclave, right, and it is used to do the training. So this was the old one, like with Intel SCX. Now it could be done with Intel TDX, and I think many of you know that NVIDIA GPU is used for the training purpose. But what about this one? Like, can you secure the data that is used in NVIDIA? Yes, we have something called Intel TDX Connect. That is also the open source, open standard things that can be connected with NVIDIA GPU, and the data that will be transferred from the normal CPU, normal storage to the NVIDIA GPU and used for the training, that could be also at least somehow protected using the encryption. Another use case, like you remember about the federated learning, right? What I said about the hospitals not willing to send it data. So Novartis was trying to work with some of the diagnostic models, right? And it works with the Beekeeper AI to at least get this diagnostic AI model to get realistic and more accurate, right? And but we know that for any AI model to be more accurate, it really needs more data, right? And more data means more diverse data. It's not only one data, right? And this was the case with as it was like a little bit rare diseases, different hospitals have their own data and they don't want to leave it, their data. So what the solution came is about this federated learning, where the Beekeeper AI will run a private instance in all the hospitals data, I mean to say in the on-prem hospital servers, right? And the one model that that we wanted to train it for those private information of the patient data, go to the hospitals, do all the training part, and update the weight to the central server, right? And in the central server, we do the consolidation, and at the end, we get the model, right? But here is also the part is that all the things are running on the Intel SCX, and even the Novartis or even the Beekeeper AI will not be able to see the data, because this is on the hardware level of encryption. So only the owner or the owner who trusts those applications running on those environment only have the access of those data that's running on those trusted execution environment. Yeah, and Intel offering some TDX extension with this OpenFL, which I talked previously. So we talked like Vision, federated AI, and now I talk like Gen AI, right? Like many times you see it. This is one project, like Intel, AMD, NVIDIA, and a lot of other people are also contributing a lot of other open source. So like open platform for enterprise AI. This is, I think, if you scan this, sorry, I think, yeah, I have another place. Okay, so like this is exactly the blueprint of Gen AI solutions, right? It gives like enterprise-ready solutions. It's all microservice based, means it runs in the Kubernetes and scalable. And this is something called uh, uh, creating your own application, like creating your own pipeline using this type of Docker containerized microservices, right? And this is all OpenAI compatible. So which means you can use the cloud service provider GenAI models. At the same time, you can have your own model running on the Intel CPU, GPU, or NPU, right? Served by something called like OpenVINO as an Intel toolkit, and you can use your everything on-prem and connect. Because it's OpenAI compatible, you can switch from like cloud to the on-prem anytime you want it, right? So this is what this framework gives, right? And Intel AMD also contributed on it. So this OPI has an extension with the Intel TDX to foster this confidential AI part, right? So what exactly it does? So like probably we have seen that there are a lot of attacks nowadays, and there are a lot of way to protect it as well, right? So there's where this example is trying to give you a type of blueprint where you can have a RAG ingestion, RAG in data ingestion, which means you generally send the data to the RAG pipeline, and another is like RAG query, right, where you do it. And when you do the RAG query, they already give you something called LLM guard. Exactly, it is like guardrails, so that you, as far as possible, we wanted to protect any type of attack that user can have it, using the guardrails, right, and the metrics. You can scan the QR code, you directly reach to this GitHub page. On this one, everything runs in the trusted education environment. So from your data to the RAG query to everything running in the trusted education environment. So like if anyone having your this RAG application somewhere, and fortunately or unfortunately the people have the access of your physical machine, like with SSH or whatever, still they will not be able to see what is the data inside. And that's what I wanted to show in this demo. So this is the pipeline that we created it, and yeah, I hope it is short. Yes. So like in the right hand side, it is this console, and on the left hand side is just the UI. So in UI, we asking the questions, right? That's what I wanted to show you. In the right hand side, we dump the memory, right? And we dump the memory, and you can see that we filter it with the questions. And if you see that all these questions are there, you can see in the memory already there. So like that's what I see. Like if someone has the access of your machine, they can easily see what is propped in the prompt, right? All the data, right? And this could be extended if you use the Agentic AI framework. Also, this is there. So now let's switch to this confidential deployment. Confidential deployment, which enables the TDX. Now you do the same thing. You do the query again, like you ask something on the prompt or like chatbot, and now you wanted to do dump host memory, right? And now when you now dump it and do the like filter with the question, you don't see any matches there. So there's nothing, because this Intel TDX created a trusted execution environment and encrypted everything. So inside even in the dumped memory, everything is encrypted, and you wanted to filter with the question. Sorry, no luck, no match there, right? So this is what it is possible with the Intel TDX, right? And now moving more to the securing the agentic AI system. Yeah. Yeah, so like we have seen, like at the same time, I want to claim like it's just some specific use cases that we have done, and we have seen like almost around 5% impact, right? And so I think many people, like last time also, like people asked, okay, this is good, and there's some other algorithms, right? Homomorphic encryption, and there's a lot of for data privacy, differential privacy, and a lot of other ways to do it. But when you use other algorithms, the like impact really in computation is almost like 20%, 30%, something more. And this is why the hardware-based technology that has like proven to be much more better and faster. Yeah. Yeah, and so like so in agentic AI use cases, so as I said, you can run everything in one trusted domain VM. Like as you see here, the like a bar line with this, like your agent, even the orchestrator. Like we know that in agentic you have one orchestrator which probably decide, okay, which agent to call, which tool to call, and everything that could be run in also in the same trusted execution environment, and your RAG pipeline, everything could run in the same trusted, because you think like you wanted to protect everything, yeah, it will be there, right? But there is also a scenario where you might have some agent from someone else, some tool from someone else, right? And you think like, okay, that is their responsibility to protect it. I will want to protect my part. Then also you can do it like just running your part inside that trusted execution environment, right? And even the inferencing could be also done in the trusted execution environment, right? So like when you run these type of things inside this trusted execution environment, it minimizes the risk, right? And it's also protect data integrity, and a lot of other things are there, like which is protected with this one. So at the end, what I wanted to say that like confidential computing is creating a trust, right? Is because like there have been different use cases, right? So there are a lot of compliance people say, okay, we see the compliance, but how you can build the really trust on those compliance, that you are offering those compliance. There are a lot of way to build it, right? Like attestation services. So like data security, integrity, these are like somehow protected, right? And also we have seen at least this type of use cases mostly in the healthcare, right? Because yeah, the data is really secure, need to be secure. In financial services, highly regulated, and of course the government services also. Like currently, there's one project going on in NRW with the like German government, like small IT department about this confidential AI, right? Because they have the public data there already. Because like people work in the government offices have the public data, so how to like save those all data, right? So this type of technology is really needed if really you think that you need to take care of the data privacy and data integrity, right? And at the same time, you don't want it to risk it, and you don't want it to modify your applications, right? So you don't want it to go in your applications and do something that, okay, it will be complied with the privacy. But if you just wanted to protect everything running in the environment, cloud environment, or like on-prem environment with the hardware level of protection, and that also could be attested, so this way help it, right? And in federated learning, yeah, this build the trust because of the attestation, and also I see that like this at least closes the gap when you have a Azure cloud or AWS cloud or like Alibaba cloud, right? They have this confidential computing environment, and you can verify it from other service provider, not Azure, right? So that you know, okay, what Azure is offering is also the trusted execution environment. Yeah, and also like at least we have seen that at least in agentic world where there's a lot of data inside the memory, it is very useful to create like really robust systems, right? So Intel drives this confidential computing consortium. We are like of course the founding members, and it's not only we. So like you can see the like Intel, AMD, like ARM, like there are a lot of other companies as like hardware vendors who give the service, which gives the capability, hardware capability. There are the like software vendors and cloud service providers who also give this type of capabilities above it. And in at least in the Berlin, we have a partner called Enclave AI, and they are like in Berlin based. If you really wanted to work with this technology to solve your problem, yeah, they will be like local champion to help you guys there, right? I think I'm done with this one. Any questions, and let me know. Yeah.
What about forward secrecy? Like if someone makes a memory dump and then at some point down the line there's a CVE, a vulnerability in NGX or GDX.
TDX, yeah.
Will someone who has saved that memory dump be able to decrypt it then?
Okay, so like you, okay, that's quite a tricky question. So like, at I say right, like from the very beginning. So we protect if the data is encrypted, right, in memory, right? If it's like TDX or SCX, if data is encrypted there and you dump it and you wanted to decrypt it later on, you don't have the key, right? For how you duplicate it? Yeah, and if you say like, okay, using the quantum computing, you can find the way to like, okay, do it. That's different way. But like the key is inside the hardware, right? This hardware level of trust, how you will decrypt it. So that's very difficult. At least so far we have seen it. Until and unless you have really the hardware level of the access of the memory card and memory like maybe CPU, and maybe like you are very pro on it to do all these type of decryptions, then probably. But so far, just by like storing it and decrypting later on with some magic is so far it has not been.
Yeah, I mean, not with some magic or like with brute force. No, I was thinking like, okay, some bug, you can trick the processor into exposing the key, like in a register or main memory or something?
Yeah, I think this is something. Wouldn't it be possible? No one knows currently, right? That will be my answer. So like, I can't say it like in future because this type of attacks is always increasing and the people are getting much more smarter. Future, no one knows it. Like, will it be possible or not? But till now, at least like this type of bugs, we have not seen it, right? And of course, there was like many times some of type of the bugs and we fixed it. Maybe the next new box comes. Again, we do the patching. But this is not like that's why I tell like, it's not 100% that I say okay we give this one and you're 100% secure. Not like that. Yeah. Any more questions? Yeah.
Do I need to be the owner of the application or the models, or would it also be possible that, like, I don't know, Gemini model or ChatGPT model is running in that kind of encrypted environment, and the provider can then ensure me that it's safe? Is that the idea behind it?
So there's two things. So like if you, for example, if you don't trust like okay Gemini or like some other providers is leaking your data or like using your data, right? On this type of scenario, you need to access that model and run it in your trusted education environment, right? Maybe you can run it in the cloud, like trusted education environment, or like on-prem as well. Like when you have this type of hardware capable CPU, so you run. That's one scenario, right? Another scenario is that when you send your data to the Gemini or somewhere, right? You always send all your private information, pseudonymize it. So for example, I'm asking, okay, this is my like car number plate and I got this type of like insurance claim, but this is not working. I give all the information, okay? So when I give my personal information about the car or like whatever, like number plate and this is my phone number, when you give it to the Gemini or like wherever you give it, pseudonymize it. I mean to say, use the number that's arbitrary. But in your application, you should be able to track it down. So when the response comes, make the user aware like, okay, this was the answer. So that way is also there one way, another way to at least protect your privacy of the data. Yeah?
Maybe I missed it, but what about CPU cache level? Does it also work there, or it's more focused on?
Yeah, it's more focused on the memory, not on the cache level. So, like dumping the cache and storing the data, like cache is very small and like okay, that is much more trickier than the dumping the memory and accessing it. Yeah. So currently it's mostly the memory, like RAM, I can say it. Yeah. Yeah. Yeah.
What's your view on replacing federated learning with mixture of experts and confidential AI?
Okay. Can you ask again? Sorry.
So we worked on a project proposal, same with dealing with confidential data, like personally unencrypted information or medical data, and using different models with federated learning. And a colleague of mine wanted to replace it with mixture of experts because we can have more customization and stuff. And I thought, okay, federated learning is like mixture of experts or like kind of advancements of federated learning, but the argument was like mixture of experts is completely different from
Yeah.
federated.
Yeah.
So do you think like mixture of experts and confidential learning works better than federated learning and confidential AI?
So okay, so mixture of like according to my knowledge, like mixture of experts is totally different, right? Than the what I'm talking about confidential AI or federated learning. So federated learning and confidential AI is probably the technology that's helping you to do this mixture of experts or whatever the algorithm you have to work on those environment. So it's not that okay, this is replacement of another one. So that's what I feel that way, right? So because like for example, if you're using the Queen 3 model, like with the mixture of expert, right? You do probably the different task with these models, right? But federated learning is something that okay, I can give you the example like in federated learning. Generally, many of you use the mobile, right? And when you chat it, you see that like because according to your usage, you get the prediction what will be your next steps or next chat, right? This is where the Google has long ago used the federated learning part. So they train the model on your devices, on your personal data, the way of you act, and they created a model that can help you to predict it there. So this is federated learning is just a technology that helps to run your algorithm different places. But algorithm is your decision, whether you run mixture of experts or you like use just native like a LSTM model or whichever model you want to use is your choice. Yeah. Any more question? If yeah. Mm-hmm. 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 Yeah, so the nice question. So like, so in whole this confidential AI talk, like we assume that you give the application access. The people who has the access of the application is someone whom you trust it, right? And they don't do some nasty things, right? The prompt injection is more like, okay, the probably you write a like a query or something that already entered inside your application now. So it's more in application level, right? Not in the like infrastructure level. So this confidential computing is more on protecting on the infrastructure layer. So which means if there's another agent which is malicious agent and it wanted to access your information from the infrastructure, they will not be. But if your agent is already vulnerable and already is infected, then sorry, it won't be able to protect it. Yeah, that's the difference here. So for that probably prompt injection, you have to have your own security level to protect those type of prompt injection. Yeah, if no more question or if you have question, we can talk later on also like today or tomorrow, right? And thank you very much for having this interactive session. I really like it.